Hello, everybody. Welcome back. Module 4, halfway. I forgot to say something last week. Did everybody see the announcement? The midterm exam. Most important thing to always remember, I don't like that Sunday night due dates like what we're talking about. That's not good practice for the world. So the exams are the most drastic change from that. And the exams are on a calendar schedule. So they close Saturday at 11:59 p.m. And only module 1 through 3 stuff. It's the same question bank as your weekly quizzes. So module 1, 2, and 3 stuff is on there. So I would recommend doing the exam before moving on to module 4 stuff. Might be a little bit easier, but just make sure you get it taken by Saturday. I will send out another reminder probably Saturday morning. Check your emails about that. Because I'm not trying to trip you up with that. I don't like this. Everything's due at the same time every week in all the classes. So got a few things to look at tonight. First thing I wanted to look at was kind of what we did first week, look at something interesting, start looking at GitHub. So first thing I want to do is something interesting you probably haven't done before. So we'll do the CI/CD pipelines on GitHub. And I was thinking just a Docker image. So we'll just publish a Docker image so that every time we make a change to our repository, a new version of the software will switch out. Really easy on GitHub too. I feel in those who've seen the BRT tutorial in the SDEV 320 class, which updated in the spring. So when you took it, it started asking for credit cards. Apparently they haven't removed that for the fall either. Oh, I see head shaking now. Oh, so we're going to start there. Then we're going to look at AWS CodeCommit, which is an alternative. It's AWS's Git repository, and probably Cloud9, which is the electron framework. So like VS Code on AWS, because y'all are all getting near graduation, so you'll be job hunting soon, and you will probably see AWS and one of the cloud things show up. So I'm going to look at that. We'll start with the interesting stuff on GitHub. Web dev opportunity. The program chair or department chair at Madison, guy in charge of SDEV down at Madison, he also runs a consulting firm. And his consulting firm is ready to make a new web page. And since he's a teacher, even though it's an IT consulting firm, they could do that. He's a teacher, he wants a student to do it. And none of the Madison students are available this summer or summer into fall for that. So he reached out to all the other program chairs across the state, all the way up to the program chair up at Lake County, which is about as far as you can get in the state of Indiana away from Madison. So I assume it's a remote position. If anybody is interested in that, let me know. And he said, just pass on his Ivy Tech email and you can reach out to him for redeveloping the website, which I think is going to be fairly short work. But he wanted to give it to a student, that way there's some experience, have that experience stuff. But he reached out to every chair across the state, so there might be some other people on that soon. So I guess let me know tonight if you want that information.
You know the language?
I'm not sure. It might be open. He'll have something. It might just be a static site. If it's not a static site, I would assume it's probably in Django. If it's not a static site, he's probably doing it in Django because he teaches the Python course sometimes too. Yeah, usually it alternates. Like in the fall, in the spring, he taught it the first 8 weeks, and I taught it the second 8 weeks for every online. And this fall, I teach it the first 8 weeks for every online. He teaches the second 8 weeks for every online. So if it's not a static HTML site, it's probably done in Django. But it might be WordPress or something. I don't really know what he has planned. But I'll give you his contact info so you can reach out to him, and then experience looks good on the resume. That's why he wants a student to do it instead of one of the people that regularly himself or one of the other people that work with the consulting firm. So first thing I want to look at tonight is containers, in particular Docker, and we'll launch a Docker image out a CI/CD pipeline. Docker and CI/CD. So Docker is a container. Those basically take the place of the old installers. Everybody is familiar with the like .exe or MSI installers on Windows, or .pkg or .dmg on Macs. Kind of same thing. One of them has a wizard you walk step by step through, and the other one just runs all the steps automatically. There's similar things for Linux, but Linux users don't ever use them. I usually create one so Linux users know that source code was tested on the Linux machine. But they're going to download, Linux users are typically going to download the source code, set that themselves. So they just need that little flag to let them know it was tested. So traditional style, we have that computer, somebody else's computer, right? Not us, not software developer's computer, some random user. So we're going to take our software and we bundle it up into a package and send them that executable, and they just load it right on their computer with all their local config, where they are in charge of those configurations. There's no telling what they're going to do. They're not us. They could decide they need space on their hard drive and go through randomly deleting files. I have no idea what this is. I need to get rid of that and start deleting things, and our software might depend on it. That can be a big problem. So Docker is a small, lightweight virtual machine. So we take, instead of putting our software on their machine where they run the configurations, we put our software on this little virtual machine, a small one. It doesn't need to be a full operating system. It's just the bare minimum enough to run this one piece of software. So very lightweight, doesn't take up hardly any size. And then we put that virtual machine on their computer, so that whatever their configurations are, it does not affect the config on that virtual machine. We control the configurations on the machine that runs our software is running on. Hopefully that sounds very, very appealing to you software developers. It gives us the control over those other people's computer, and if they break their configuration to the point that the virtual machine's not going to run, they've basically destroyed their entire computer. And it doesn't come back on us at all, because all of their software would quit working by the time the virtual machine quits working. So there's lots of different versions of it. Kubernetes is probably the most powerful. It's been around for a while. The idea came out from Java itself. That's how they made Java cross-platform. Java comes with the Java virtual machine. The programming language only runs on one type of virtual machine, and then really good programmers at Oracle configure it so that virtual machine will run on any system. So an extension of that, it's cross-platform. Whatever we're doing, we put it on this virtual machine, and then we give them that virtual machine. We do that as a traditional installer, but we can do right where we have version 1 point, so version, release, patch. So maybe we're on software version 2, the third release of it, the third major update, and the fourth small fix on that. And we push those out periodically, which kind of relies on the user to hit that update button. So not ignore that you have updates, notifications, all of that stuff. CI/CD is continuous integration, continuous deployment. What this does is we add another step here. So we have our repository. So we only put our code on the repository. That virtual machine automatically pulls from the repository. And then what's on their system, instead of the full software, we only give them a small script that says, pull down the code. So whatever the latest version is, they always get that. So we don't have to do these periodic updates. We'll choose a branch. So for example, tonight, we're just going to put it on the main branch of the repository. Anytime there's actually we'll do a push here. this would be a pull. And we'll set up GitHub to push out a new version every time we make a change on the repository. If we commit some files, if we delete some files, if we fix a typo, if we make a new branch, we can set it for any number of things. I guess a new branch wouldn't necessarily work. If we merge a branch into the main, to keep it simple, I was just going to put it on the main branch. Anytime we make a change, commit a change on our main branch, a new version of the software comes out. And then the script that goes on the end user computer is actually just a script that pulls that latest version. So it just, the script, their computer only knows the URL of where to get our software. That's all we install. Every time we make a change, it's a continuous thing. It's continuously deployed. Every time they open the software, they get the latest, newest version. You have to be extra careful about pushing out. You want to make sure the main branch is the one it's pulling from. Usually people don't do it from main. Most people do it from release. They'll create a branch called release, where they're extra careful about what goes on the release branch. Right. But then they always open that latest release. No need for updates or anything. It's handled by the software developers, not by the anything in between. So automated processes and setting it up on GitHub is almost an automated process. So I thought that would be an interesting one to start with. I'm going to do a Java project tonight. I was saying this, I think, before anybody hopped on the Zoom call with people in the classroom. This is something y'all have part of your group project assignment is going to be to do this. It's really easy. And that's doing module 8. So when we get close to module 8, even though we haven't even randomly split into groups yet, I assume everybody's going, from what's happened so far, I assume everybody's going to be using Python for the final project. So we're going to do it in Python right before, like module 6 or something, to review all this right before you have to do it. So I was just going to do something small in Java. I was just going to print hello world or something in Java. I guess we'll go kind of slow to talk about the parts in Java. There's also an update I want to show. Depending on when you install Git on your computer, there was a change. And when we do Git pull and it merges things, there's a slight change with the latest version. So I want to force the error that slight change causes here this evening and show you how to deal with that. So a couple things to go over, but hopefully this is going to be an interesting one. An important modern tool in software development. So I'm going to go over my working thing and I'll just create a new folder here. What's the name of this? This is going to be, I'll call it Hi There. That sounds like a good name this time. So I'm going to create this folder called Hi There. And I think this time I'm going to do everything in Sublime. So you might want to follow along VS Code or use the terminal and text editor the way we've been doing it. But I say everything in Sublime. I have a Terminus, which pulls the regular terminal into Sublime to run the code. So it's still working in there. So I'm going to do start Sublime and just put a dot there. Might not show up on the screen. I did the dot for this folder to open the whole project. VS Code, you would do the same thing. So put code and then a dot, and then it automatically opens the folder and stuff. Do the same thing in the terminal. When I have Sublime set up with the PowerShell connected. Just to do the whole thing, I guess part of deciding to do this is to show that integration with GitHub is not unique. So do the stuff we've seen before. So initialize the repository here, and I'm going to add a README, which I usually do in the terminal instead of hitting the Sublime buttons. So I find that, I don't know why, I just prefer that method. There's more than one way to create a new file. I think everybody's aware of that way. So this is example CI/CD pipeline. CI/CD and in class example. of a CI/CD, continuous integration, continuous deployment pipeline to push out new Docker images anytime we change our main branch. So say that, close that, nothing new yet, right? Add those files, all the things we've seen. I have Sublime set up so that it works with PowerShell instead of some of the other options for it. And git commit. So this will be the initialized repository. Add in a README. And notice over in the left-hand side, after I added those files, got a green symbol, well, arrows in this case. So there's little icons. Pretty much any of your major text editors will have that. There'll be some sort of visual cues right there in where you write the code. And README to start things off. Some sort of message. We've seen all this before, right? Save that, close that, and those little dots went away. Actually, I didn't want to README. I'm gonna do a README on GitHub so they have different histories, because that does apply to an update on GitHub as of June. We looked in the first day that changes in the latest version. So I want to make sure and show the one thing that affects the low end. Usually changes in software like Git are big things, really, really advanced special cases that 90% of people are never going to see. But there was one this year that does affect just about everybody. So we'll see that. I'll force that down. So I'm going to get rid of that README and so remove readme.md. I'm going to make that right on GitHub when I initialize the repository there. That checkbox for initialize with a README and a license. I think everybody's seen that before, right? So remove the README, and then I'll create, instead, I'll just go ahead and create the Java file. Create hello.java. And the name does matter. So Python lets us name the file anything we want, but whatever objects we want in it. Most other languages, that's a restriction. We can't. We have more control over the system. Like this is just gonna be print hello world, and I'm just gonna do a basic one, but just with the core Java language, we probably have 50 different ways we could print to the screen. We could set up a buffered string and send it 4 bits at a time, or 4,000 bits at a time. So stream, like you all have probably heard in our modern law, that does refer to a programming language. It's how we send things. Netflix streaming is the one that became common language from. That does come explicitly from Java. It's named after the Java objects for transmitting video. But we have more control, so the name matters. I'm going to make an object called hello. Actually, Greek might be hello word, but it has to match that. So just talk about some of the keywords, because I think everybody's seen Python. First thing is we have to say it's public. Public means accessible by other software, not necessarily the human. Eventually the human, but the human accesses it through the operating system. And there's layers and layers and layers before we get to the actual program we're running here, right? All that abstraction. So public means accessible by other software. A class means we're designing an object, because Java only allows objects. Then we have to give it a name that matches the file name, and some curly braces to block off what's going on. And actually in Java 21 that comes out in September, it was supposed to come out in August at one point, they pushed the date back. This part, if that's all we do, we don't have any inheritance or interfaces or anything, we can omit that. So Java's getting easier soon, and we would just do that to create the class. But until September, we still have to type all the keywords. But they all have meaning. It's accessible, creating a design. This is what we're going to call it, and that has to match the file name. And then we have our main method. Again, it's the main method. It has to be public. This keyword static, which definitely does not show up in Python. Static means there's one and only one copy. And if there's only one and can only ever be one, we can get it from the class, not an instance of the class. Right? We're instantiating objects. Has everybody seen that before? Programming classes. Our very start point, there are no objects, so there's no way we could grab it from an object. So the only way we could get it is to go back to the actual design for an object. So static means one and only one copy, and that means it comes from the class, not from an instance of the class. Static variables, like you get a counter, so maybe you have an employee object, and you put a employee number. Every object made from that employee class shares that same variable. So that's another way to think of static. There's only one of them, so any objects we make from it share the same thing. But in this case, we have to start somewhere. Python automatically starts for us, so we don't have to worry about that. We just start running our code, and that starting point happens in the background. Keyword we have to include here. So it's static. Whoops. I don't know where that typo came from. It doesn't return anything. We do have to explicitly say what type of thing we're returning. Void means not returning anything. You would have heard that word about Python, but you don't have to explicitly type it. And then it's called main. And since we actually always start things from the command prompt, and anytime we have a GUI to click on, all that's doing is calling an instruction in the background. We could pass in a string. We could pass in some strings, some arguments to start with. So in Java, where we are explicit on everything, we need to leave an array of. We need a parameter to accept an array of strings in case somebody wants to send one when we start a particular program. Just explicit about things, that's changing as well. Come September 24th. Obviously, the main method is public static, so we don't have to type that. And then this is overloaded. So there's two versions. So come September 24th, the Java main method is going to say void main. And then it'll be a lot easier to type.
Is the course going to be updated for fall?
If you take it with me, the online one is yes, the online one is being updated.
Well, because I have it my second half of fall.
So second 8 weeks. They're doing a new one right now. I don't know if Java 21 is going to be in there because it comes out then.
Right.
So it's probably going to be a year or two before it really gets used much. I will be teaching it the first 8 weeks, and I will definitely record it. So I will definitely include it. So I can send you the videos from when I included it in class.
Absolutely.
Because yeah, on the day it comes out, we'll still be doing everything the way it's been done for 30 years. But we want to know the things. Oh wait, actually, it's going to talk about it. Yeah, I just gave Amanda the thing today. I just sent her some videos today to like news releases on Java and stuff, so that you all will at least have reports about the new stuff coming out. I sent her several. One of them is my favorite comedian report on new stuff, the code report. It's really quite hilarious, and she's probably not going to choose the humorous one. She's going to choose the serious one. It's very detailed and it's almost like a tutorial walks through it. But this is boilerplate code, so that's what's changing. That stuff that's the compiler can type that. So they're taking out the parts that the compiler. If the compiler can type it, the human doesn't need to. But we have absolute control over it. We're just going to print hello world. So I'm going to access the system, which the system is static, right? There's one and only one operating system we're running the program on at any given time. So to access a static variable instead of an instance, we give the class name itself. The system has several things about it, one of them being the output. And then that output has some methods we can call, so like print line. So the system class has a subclass called output, which the default one is our screen unless we change it to something else. Change it to the printer, the NIC card, so we're transmitting across the network. And I don't know, hello container. Yeah, since we're going to container, I'll just put hello container instead of hello world. A slight change, but I wanted to talk about those keywords, and we'll do a Python example right before you all have to do a CI/CD pipeline, because I assume everybody's going to be doing Python there. So the next step, I'm going to type a couple things here, but you may have noticed that when I said send out that message to install Docker, did everybody get that installed? I see head nods. It does require a restart. I did not send a message to install Java, because Oracle is kind of leaning towards stop installing Java on every machine and start putting your Docker code on, put your Java on Docker, and then just ask for the Oracle version, the Oracle virtual machine for Docker, because then they have control over it, the people that make Java, and it's sort of a recognition. I'm going to go through the steps so we can see what it is. Java is a compiled language, so instead of line by line like Python, grab line one, run that, come back, grab line two. Interpreted language, this is compiled where we take all of it and turn it all into machine stuff at once, machine understandable stuff at once. So we have to compile it. And to do that, our instruction is Java C, which if you don't have a Java development kit on your computer, this isn't going to work. But when we get to Docker, there will be a Java development kit, which is actually what they're recommending. Like, stop putting it on your own computer and just put it on Docker. So the Java compiler, and we want to compile hello.java. And if there's no typos, it'll compile. It doesn't show in Sublime. If I come back over here, notice it made this hello.class file.
Yes.
Let me put a typo in here. So maybe I take the Y out of system. So now there's a problem if I try to compile it. This what we get the errors here. Instead of like Python where it can run halfway through before we hit an error. We see the errors before it even starts running.
It's the good and the bad of
They have advantages and disadvantages. There are advantages and disadvantages to both. And this one, we have multiple languages. We choose the best for our situation. Let me compile that again.
I used to use like option explicit on VB because you lose some of the compiled language.
Yes.
Compilability.
So we're going to draw our compiler, and if there's no error messages, no news is good news from compilers. They give error messages, they don't say anything. And then we type Java to start the Java virtual machine. A very, very early foray into this, making things cross-platform. We install a virtual machine instead of our actual software. That starts the Java virtual machine, and then we pass in the name, and the Java virtual machine only runs .class files, so we don't have to put the extension in there. So that file we compiled, and then that should print out a little hello message. So that's our simple software. Obviously not a rather trivial example there. We're talking about Docker and CI/CD, so I didn't want to get too much into it, but I want to talk about those keywords. Because you all know how the class is. If you take Java class online, you're going to see a whole lot of copy this code, and they don't tell you what it means. They'll tell you what static is. They'll tell you to type static a bunch of times, but never tell you what static means so that you can use it yourself when you need
I
it.
actually went through a whole Duke University online course.
You probably said it.
And they never, they show it to you, and they basically said, you don't need to understand what this means. Just know that you have to do it. We'll get to what it means next semester.
Oh.
Like they said, basically they're 200 or they're 300, whatever. The next class.
They use it like a commercial to keep coming back, the cliffhanger.
Kind of like, yeah, they went through this whole thing, but they just said, yeah, you really don't need to understand this. Just know you have to type it.
So yeah, the big ones are the start point, or if there's only ever one. We can only ever run on one operating system, so obviously that's static. Our math objects, those are static, because we don't need multiple cosine objects, cosine functions. We can use the same one over and over and over again. There's no variance in the object. So things at the very beginning and things that we don't need multiple ones of. So there's that, there's our thing. Notice the little icons in Sublime. It turned red. Files have been added, but they haven't been. Files have been edited, but they're not staged. So we can stage that. Hit add dot. Back to the stuff here, and notice that Now we have a contains added and deleted files. I was expecting it to be blue. I wasn't sure what I was reading. Cover, but all of our text editors do that. I just wanted to make sure whatever IDE you're using, you notice the visual cues, because the Git ones are usually small. They're not very big, not very pronounced. So that gets our application, but we want to do it the modern way. We don't want to trust a user to just put this on there because we're asking for system. So if the user starts messing with their system, that could mess with our software. And yeah, when we have absolute control, you're all probably used to Python, where there's only one way to print to the console. Just in the language, I quit counting when I tried to count, just in the core language. There's lots and lots of ways we can get those letters to the console, not just the one print method. We have absolute control over it. We could set up a buffered stream and send it 4 bits, decide how many bits go at a time. It's Unicode, we can send it 4 bits at a time, so it takes 4 pulses to get all 16 bits for your letter there. Or any type of stringing things, but the trade-off for those extra words is absolute control over everything that's happening. So we want to make this part of Docker. So to do that, we create what's called a Docker file. Sublime.
Should we commit that add before?
Sure. I was going to commit it all at once, but commit.
I know for the history part of it.
Yeah, you can go ahead and commit. I'll commit it in a moment because it's there. It's not going away. Since this is a Docker application, we really haven't finished the application till we make Docker, was my thought. But that's personal style. Some people like to commit every time. Some people like to do a minimum number of commits, and whatever makes the most sense to you. And yet the text editors give us visual cues so that we don't forget about it. So we need to create a Docker file, and it is just called Docker file. No extension. It's for an automated process, so it has to be spelled exactly correctly, case sensitive. Capital D, jam both words together, and no extension. And this is where we write the instructions for the virtual machine to carry out. So the first instruction we need is what are we running? What language do we want to install on this machine? So we use the keyword from for that, and the Docker keywords are all uppercase letters. So from is an instruction for Docker. And then Docker has massive repositories, and we just choose one. So open JDK:17, I like Java 17 - Oracle. I don't want just anybody's version of Java 17. I want to make sure I get the one that came from Oracle, the explicit one. So that's basically saying use Java, and in particular, which version of Java to use. I'm jumping ahead, so you are more familiar with Python, right? So you would probably say something like from Python 3 or from Python 3.11. The particular version you want to use, the same thing there. We're just doing it in Java, and we'll look at the Python one in a couple weeks. I wanted to switch it up and not look at everything in Python. Is a big part of it. Is some variety.
The world doesn't revolve around Python yet.
It is not. So next off, we need to say where are we going to conduct our work, and that is where are we working on our virtual machine. So it's a virtual Linux machine. So it's the present working directory. If you've used Linux, the PWD variable, or Mac, your PWD. Where are we setting PWD? And it's a Linux machine, so it's completely blank at this point. So we just have to set one thing up. So one thing to remember is for Linux or any of the something Unix like a Mac or Linux machines, start with /, unlike a Windows where we start with a C drive. So / is your root, and then a couple folder names. I'm going to put it in opt. That's one of the places where software norm traditionally goes in a Linux machine. So I'm going to just put it there. Even we're not restricted. opt, and then hello. That sounds like a good name for a folder. Holding hello world application. So that's where we're going to carry out our work. Now we need to bring over our files. So copy any files we want to bring over. I'm going to bring over hello.java and then dot for the current directory again. And remember that the current directory is referring to this one we just created on that virtual machine. So the dot is referring not to the one on my Windows machine, but this /op/hello in this case. Don't need to copy the other one because I'm just going to, I can compile it here. That's why I didn't include in that message install Java, because we can put Java on our virtual machine. Then we don't even have to have Java locally in order to do all of this. So we can, the next thing we're gonna do is what instructions need carried out before we actually run our software. Since you all know Python, let me do that one first. So pip install, don't copy this line. I'm just typing this because this is one y'all probably know. You would probably run that first, right? Install requirements.txt, and all your dependencies automatically get installed on that computer, so you know everything's running. Back to that picture, you don't have to worry about the user getting rid of any of them. You're in charge of that configuration. For us here, though, we need to compile that code before we run it. So the thing I put in the terminal just a minute ago. Have the Java compiler, because we opened the Java development kit, or we started with the Java development kit. So we know the compiler's there. So have the compiler check out hello.java. And this is what Oracle is leaning towards. They haven't made the official announcement, but they've said that they are leaning towards that this is a better way to do it. Don't even bother putting Java on your local machine. Put Java on Docker, because then you have a virtual machine running in a virtual machine. So there's layers of protection between you and that end user that could mess up your software. So we'll compile that, and hopefully at that point it runs. And the last thing in the Docker file is, what do we want to pass into the command prompt? What command are we actually saying to do when we start our software? Which is the same ones we use. So have the Java virtual machine, and these we enter as a list, comma separated, no spaces. It's going to a terminal. So space delimited things, but we pass them in one word at a time as a list, and it will split it up that way. I don't know who chose the syntax that way, but each word that you would type in your terminal it becomes an item in the list. So Java, hello, and we don't have to hit the dot. We'll have the hello.class by that point, the compiled version, which is in bytecode, doesn't go all the way to machine language. But the Java virtual machine only runs .class files, so we don't have to put that extension. So that's what a Docker file looks like. That's the instructions to create a virtual machine that we have complete control over, and keeps us safe from that end user messing up our software and then jumping on Facebook telling everybody that our software gave their computer a virus or something like that. They have to completely destroy their machine in order to break our software. And if they do that, then they can't single our software out from everything that's going to be on their machine. It'll all break at once. So we don't have to worry about those things like people installing your software, spilling coffee on their laptop, and then telling everybody that they know that your software gave the computer a virus because it didn't work anymore after they installed it. Smells like coffee though for some reason. Keeps us safer from things like that. So that's the Docker file. And to create Docker, we can install it all in the background. So in the long run, you would probably install it all in the background and do some more background scripting there. Docker desktop is a nice one. Or you could just copy those entirely. You could make a Linux virtual machine from scratch yourself. And ultimately, there's some big advantages to that. Oh, I forgot to delete stuff. Let me delete what I have going on in Docker. So containers. So we use images to create containers. So software is we are creating an image of a virtual machine. And then when we actually run it, that is the container. So kind of like class and object to relate it to things, the image is like a class file, and then the container is like the object created. We don't need desktop. That just includes the full version of Docker. So that's the easiest way to get it installed on your computer. We'll do it in the terminal. So if you've installed that, you should be able to go over to your terminal and write Docker do images. Actually, it's probably a -v. Okay, yeah, Docker -v. -v is usually a good way to check things. I always forget about that. Try to do something fancy. So we can see our computer knows about Docker. So Docker images -a gives us a list of all the images there. Y'all just watch me delete all the images. So obviously there's none here. Repository tag, image ID created and size. We need to fill out this table with some images so we can run things. So to create one, say Docker build the file path. So now the doc does refer to the file path here on Windows. So this folder that's showing over on the left-hand side is Sublime on my screen. The one that has our Docker file and Java code that we're going to copy over to the Docker. So that -t means name for some reason. When it shows up in the chart, it's under repository. So apparently T for repository name. There's tag and title in that chart, but T stands for repository name. I have no idea who came up with that, but it bothers me. Docker was built by people that speak English. It was built by Americans. But -t for repository name, and then some sort of name. I'll call it Crete here. It does not have to match our software. It does need to be in quote marks though. Even if it's a single word, it does need to be in quote marks. So when we do this, we can see the steps. It load the build file. So there's the build file. We wanted that Java machine that Oracle pushed out. Loaded that pretty quick. Copied over the Docker files. Then the instructions for what Docker is supposed to do is on that other machine. Docker ignore, but from git ignore, I think you can figure out pretty quick what a Docker ignore file does, right? No surprises there. Transferring stuff, loading data, starts running that, sets up our working directory, copies the file over, runs the compiler, and gets to the end. And notice that it didn't do that last step. It didn't do the command that has actually run. That's what it does when somebody starts the software. So now, clear that. If I do Docker images -a, which is what I almost did just to check that it works. This is one of the ones we do most often. So you can see under repository name is that -t parameter. Even though there's tag and there's also a title in here, but -t isn't for title either. We have to pull up extra things to see that, but the repository name and an image ID. And we can run it from the name. That would be a problem in a minute when we do the CI/CD pipeline. Because when we set up our pipeline, the repository is going to be a URL. And when we have the URL, we can't use the repository name to run it. So right now I could say Docker run -ti is interactive terminal and run Crete. And we get that. We get our message spit out, which was all this one did, but we got more interesting software. Right. The point of this example was Docker. So trivial software that it's running, but your software is built separately. So your big interesting software, some of y'all have some awesome projects going, by the way. What I've seen of them so far, great ideas and things. They all seem to be moving along. So you have big fancy software, and then all of that would run when we ask for the container. So what we install on the end users thing is really just a small script that does this in the background. They double click on the icon and it says Docker run TI, or just Docker run if you're going to open a GUI and you don't need the terminal from it, which obviously you can tell what Docker intended for you to do with, right? Throw out a GUI, not do stuff in the terminal. Since we're using a URL, we probably might as well go ahead and do the ID now. So I'm going to go over here to this ID, copy that, and do Docker run -ti, and then paste in that ID. Which is kind of like the Git hash codes we've been looking at. That's actually it's actually 256 characters long, but it goes backwards from what we would think in English reading left to right. So our smallest value is the leftmost. So it increased the number of columns increase going rightward. That way, until we get something absolutely massive, those first couple digits are enough. Just like we've been seeing with GitHub. We have the bigger hash, but we just need the, it's a much bigger number here, but we just need 1 to 1,000. We don't need to worry about 38 billion. We don't even need that many, but that's how how we set up the containers. That is really good form. That's how you're going to release stuff in the modern world. Then you could make a traditional installer for Windows EXE or MSI. EXE has the the wizard you walk through, and for that you just run new software. You can type it. I like to do it in classrooms because when a computer types it, you all know how quickly computers type text files. It usually takes about 4 minutes, and you all know how quickly computers type text files. So if it takes a computer to type 4 minutes to type a text file, just imagine how long it takes you to type that text file. There's nothing hard in there. So it's a perfect process to automate. You would just run it through software. In MSI, that's the one where you start and it runs the game. Same thing on PKG and DMG, right? On a Mac, PKG has a wizard, you go through all the steps, and DMG, you just click on it and you drag it to your applications folder and it all automatically installs. So we can do that, or we can set up our CI/CD pipelines, which GitHub is really, really easy on. I can move Zoom thumbnails out of the way. Let me make sure. Oh, but you all are all looking at that on your local screens, aren't you?
You can use the little minimize on top.
Yeah, that's what I was going to do. Get those out of the way because we don't need to see them here.
Yeah, I'm looking at it here.
Yeah, I think all 3 of y'all logged on. Right?
Yeah.
Yeah, but even before the pandemic pushed everything to Zoom calls, I still broadcast the lectures because software development, we're looking at text files. It's a lot easier to read a text file on your computer because the labs were never full. So even labs only had 1 monitor, people could log into this computer next to them. So GitHub, let's go create a repository. Oh, now I need to commit this, don't I? Git add dot. Notice we have different things. We have new files in green, circle, open circles that haven't even been added, and a red one to indicate there's deleted files. Git add everything. So now we have the little flags, no circles left. Git commit, and this is going to be our application. Create Docker application. Made the app and Dockerized it. That is the actual run without to Dockerize.
No nerd made that up.
Or if we generalize it, instead of the particular Docker software, it's containerized. So now over to GitHub. Let's create a repository here. GitHub.com, create a new one. You all have seen this before. And this time I'm going to give it a name. So hello, Docker. I think will be their unique name. Okay, that's available. So description and in-class example showing CI/CD pipeline to publish Docker image and GitHub packages. It's going to be public. Add a README. I'll add a license. The GNU license sounds good. So all that looks good. So go ahead and create that repository. Nothing new there, right? Everybody's seen that. Over here on the right, if we scroll down, there's releases and packages. As you can tell from the description, we use the packages one. Grab the URL. We're here. Clear this out. Git remote add origin. I remember seeing that before, right? And the URL to our repository. So now we have the local changes and the previous changes. So up until this June, when we said git pull origin main, it automatically merged it. It automatically merged. Oh, refusing to merge unrelated histories. So depending on when you install Git on your computer, you may not see that same error message I just saw. Allow. This is a long name too. So what we want to do is the git pull. I'll clear that. Clear the old stuff. Git pull origin main. So if you had Git on your computer before we started this class, so prior to June 5th or June 2nd is when it came out. So if you had it in there from previous semester, you wouldn't have, you should have not seen that message. But we have to say allow dash unrelated histories, plural. 2 dashes like we've seen with many Git parameters, and then a single dash between the words fully spelled out. Pull it down, allow unrelated histories, and this way it doesn't merge. So we see all the little plus signs. Everything was added together, and we can see them over here now. All the files came down, everything's up to date. So now I like to just go ahead and add everything for good measure. It just did a merge, so it all should be up to date. So nothing to commit. There's nothing to do, but we've got changes. It is definitely not the same as our remote one, right? Because we had those local files. So git push origin back to the main. And it's everything's up here now. So we have all of our instructions for our software and how to create the Docker image. And then all we do when we get to the end user computer is run that Docker image. So we have our instructions here, so we can go ahead and do that right on GitHub. This third tab over, everybody see the actions tab? When we go to actions, it will probably predict this. I've been doing a bunch of things. Usually if it sees a Docker file, it gets a really good prediction. It predicts that right off the bat. So I want to search for Docker image. So if you don't see Docker image right up at the top, usually if it sees a Docker file, it will automatically predict that. But I'm playing around and doing odd things, pushing things through and messing up its prediction algorithm. So it's probably predicting wrong for me, and I didn't really look closely, but some of those might have been new things. It might have just noticed that I was looking at new things every time I went on here. But we want a Docker image. Does everybody see that after searching if it wasn't there already?
I just tried to catch up because I had that unrelated thing that popped up in my.
Oh. So under actions, search for Docker image if it doesn't predict. I'll give it a second, make sure everybody catches up. Y'all got it? Then just hit configure, and we'll see something that should look familiar. Oh, it's ready to commit a YAML file. So here's this file. We'll talk about it in a second. Just go ahead and commit it. And add a message if you want. The commit button's in the right now. They did move that. Commit buttons used to always be on the bottom. With the latest update, the commit button's always on the right. And we have the Electron framework there right now. So Electron framework, which was updated since we looked at that last week. So it first appeared a couple weeks ago. There was an update since we looked at it last week. So it is currently being improved. You can do all of your coding right there in GitHub and not have to worry about VS Code locally. Or if you're not by your machine, all you need is internet access to do it then. So here's the YAML file. It created that. Notice it also created a new folder. So it created this .github folder. And inside of that, it created a workflows folder. And then it put our YAML file in there. Let's pull that down. I'll go back down over here. I think that's still on the clipboard, right? Here, git full origin main. There we go. So now we got the GitHub folder and then that a workflows folder. And on the assignment where y'all actually have to turn this in, I did put 2 videos where they explain them. Both of them talk really, really slow. I was able to follow them both with double speed, no problem. For some people, I use double speed and pause when I'm following videos. Some people like the slow move. They're both good videos to follow along, and they explain every step for these automated files. So YAML is one of those that has the recursive name. It refers to itself like AML, and it stands for YAML Ain't Markup Language. It's key value pairs, but key value pairs are sort of hashing. So internally, it uses key value pairs in the text file, but then in the background, it's a tree. So for anybody that's seen data structures, we get the advantages of key value pairs, which are easy in the text file. We don't have all those opening and closing tags like XML or HTML, if you haven't worked with XML much. So the key value pair is easy to type, but it turns into a tree like XML, which is a better structure for the computer to deal with. I'm not a big fan of things, but we have different keys. So the name is Docker image CI. Notice how that matches the name of our file, kind of like we saw in Java earlier. Or the reason I chose Java, because Java and YAML both kind of enforce that. That'll be important in a minute. So when do we run these instructions? And hopefully you can look at that and tell what that's saying to do. If we push to the main branch, or if we make a pull request to the main branch. So basically, anytime we change our main branch. Then what is the job we're running? Key value pairs are nice, especially when they have good people put good keys in there. We're going to build something. Runs on Ubuntu latest. So this is not what we're building. This is what the repository is doing. So this is over here in my picture. Let me stop the screen share. So runs on is what's called a runner. So if you saw this in the SDEV 220 class, I know it happened when Tia was going through there. Some point in the spring, they updated that tutorial that that class shows, and it started asking for credit cards about runners. So this is the runner. The repository is going to spin up a server, just a quick temporary server. For those who have seen AWS, it just spins up another virtual server, and this is where it runs all of our code and pushes out the virtual machine. So the runner, as in where we run the YAML instructions at. There's Ubuntu latest, Mac latest, and Windows latest. They're your 3 choices from GitHub. And you can turn it into a list and just run it on all 3 of them. That way you know it's going to automated test casing. Automated test cases. Then you know your stuff's going to work. What are the steps? We're going to check out the code, and this comes from GitHub Marketplace. So the uses part, we get that from GitHub Marketplace. And just search for that, which is just github.com/marketplace. And down here, all the things we can do: Circle CL, image bot, rewind backups, code factor. You see, there's lots and lots of things that GitHub already built for us. We went checkout. If we search for checkout, here's the YAML instruction it's doing. So a bunch of references, some things will fill in automatically. We can do SSH known host to limit what machines it's can push that through. A big YAML file of instructions is what's going to run there. But they already put that together for us. So all we have to do is ask for it. Give it a name, build the Docker image, sounds like a good generic name, and then the instructions to build. So I'm going to save that. There's no nothing to commit. We didn't change anything. We just looked at the stuff here, right? So I'm going to push it back to the repository. Git push origin main, and did it do this? Okay, yeah, it did it. Everything's up to date. So it told me everything's up to date, so there's no changes. But I did push to the main branch. So I activated that script. So over under actions now, notice it's not what action we want to carry out. It tells us what actions it's already carried out. There's a new button if we want to do more than one. That one ran quick. Oh, actually, that one ran when it added the file. So we click on that. We have a successful build. We can see all the steps. It set up the job, checked out our repository, built the Docker image, then cleaned up after itself. This default script, I looked and looked and looked and looked, and I cannot figure out where it put that Docker image. I'm pretty sure it left it on the runner because we didn't say anything, and that was just a temporary server that has probably already been deleted since this job ran 6 minutes ago. So it's probably long since deleted. I clicked every button in GitHub, I think, trying to find that. I could not figure out where it went. But that's not what we want to actually do anyway, because we want to publish it. We don't want to just build it and stick it on our repository. Which, yeah, I'll show you. Notice there's a blank spot here. Instead of build on the runner, we want to build it to our repository. Just put your URL there. Might as well show that, but that's not what we want to do anyway. If we're building that, we're going to send it out. So I'm going to search publish Docker image on GitHub. On GitHub. I think that's what I'm searching, something like that. Something to get to this page. GitHub publishing Docker image. And here, there's some descriptions. Y'all can read through that. Then the first one, published to Docker Hub. We don't need to go to Docker Hub. We can pull it from we can just go to GitHub now. Here's my plan. If we scroll past that, then we have GitHub packages. If we keep scrolling, there's different YAML files we can copy and paste from. I'm gonna hit the copy button here and bring this down to a new file, and paste that in. And we'll copy bits and pieces of this over. Actually, almost all of it. Yeah. This is pretty much the only part we're not going to copy, but I wanted to talk about that. So search publishing Docker images on GitHub and scroll down to the GitHub packages section and just copy all that code down. And let's look at that really quick. So we already have a name and we already told it when to do our script, and we know that part worked. So we don't need to switch to another one. This next one was missing from our script. What environment do we use? What environment do we want the output of this to go to? So not just on the runner after the runner finishes, send it somewhere. This is what was missing from that earlier. So I want that. So I'm going to copy over, and it looks like that goes right after column. So underneath of on, I'm going to paste that in there between on and jobs. So now it's going to send it somewhere. Then jobs builds on Ubuntu latest. We already had that. Oh, but they added something. They added read and write permissions to that Ubuntu machine. So let's copy that over right after the runs on. Oops, I didn't mean to zoom out. So after that, add the permissions. And then we get into steps. Well, we already have checkout repository, so we don't need that. But the rest of these are different than our steps. So then we'll copy the rest of them. And make sure you copy that dash. That dash does mean something. If you see where it's at, notice it's before the name every time. Or in our earlier one, steps, it's before uses, and then before name. So those are different processes. So make sure you copy the dash. That was an error I got earlier, or when getting ready. And we can just use that uses we had earlier, but change the steps that come afterwards. And all of these other things, those are variables in GitHub. We already have those variables instantiated in our GitHub repository. Y'all probably just never seen those variables written out. But hopefully everybody in your software developers, you knew there was variables involved in GitHub, right? So all that's in there. So save that.
So I'm sorry, I'm trying to see exactly where you, because we have steps uses in our file, but you copied more.
Oh, so everything after. So we had steps uses, and then we had a name for it and just run it.
Right.
So we're going to replace that
With everything, bro.
with everything in the steps except for the checkout, because we already had checkout. And now I'm going to go ahead and delete those. We don't need that other file there. Does all that make sense? See some head nods in here. Notice how it's pretty much all automated for us too, right? So git add, let's put those changes in the repository. Everything went from dots to flags, so it's ready to go. Git commit. And this is publish package. Change YAML file to publish our program to GitHub packages. Save that, close it. It's committed, so now git push origin main, which is when this script's going to run. So push it back to the main. Looks like it's all okay. If I come back over here and reload here, if I click in here, we'll see the new version of it. So we see that new version pushed up, and if we go to actions, oh, it failed. What failed? I wasn't expecting that to fail. I was going to put a fail in a second. View workflow. And YAML error messages look like this. You have an error in your YAML syntax on line 26. Let me pull up. I got this example already just to be ready for this. I go in here. What is line 26 here? Name uses, all that should be good.
I have line 22.
Maybe the error is somewhere else. Well, I was hoping to be finished by 7:15. This is the last step. I'm just gonna copy all the steps. Let me go back to that last page I was on. I'll just search for it again. So search for GitHub, something like that. GitHub packages, copy this down. I practiced this like 4 times to hopefully avoid errors when we went through it tonight, but I missed something. So I'm just going to grab all of the steps this time, because really the only change they did on that checkout was they gave it a name. So I paste those in. Don't notice any differences. Git add dot, git commit. This typo. Oh, good. Commit. So it's up there. Go back to actions. Oh, okay, it's running this time. So I apparently made a copy and paste error while talking and typing. Were the others following along able to get that to run?
That's what I'm fixing.
Yeah, I'm not sure what I did. I apparently made a copy and paste error, but notice it's running now. That's usually a good sign. It won't fail to, at least won't fail to a much later step. And while that's happening, there was an error, and this is an automated process, right? If I jump over to Gmail, look what it just sent me.
The fixed typo still.
We'll look at that in just a second. It sent a message saying that failed. We don't get anything for successes because that's what's supposed to happen, but it's an automated process that we might not know failed. So it does automatically inform us. Okay, so I got a check mark. So we'll look at yours in just a second, Nathan, so see if we can track down that error. Because now if we go over to packages, notice under packages, we have a new release. And says to install this software, run Docker pull in this URL. I'm going to copy that, come back down here. Docker. Oh, wait, I just copied it. Paste in that thing, the GitHub. See how easy it is to make that? So it pulled it, did all of that. And if I do Docker images -a, we now have that repository on here. So I can grab that ID, copy, Docker run in the interactive terminal, that ID, and our software runs. And notice that what we would install is just these scripts. We would say, instead of having the software installed locally, we would just give them a small bash script or batch or bash or PowerShell script. One of our terminal scripts that says, pull from this URL, get the ID. Getting the ID is a little bit copier, a little bit fancier when we have to have the computer copy and paste. These are objects. So it would be x equals Docker images -a, and then we could say x dot image ID, which is obviously an array, making a table. So index 0 is going to be the most recent one. So it's not that much more complicated. Things you all know how to do. And then we would say run it. And then they always get the latest version off the version right from here.
Disabling auto update.
Hmm?
So much for disabling auto update.
Yeah, because there's nothing to update. We have the code. They never had the code. I could come over here and change this hello container. Oh wait, that's not it. We go to this one. Could have used the simpler editor. For some, I'm going back to the simple editor. There's a regular edit too. We don't have, if we don't need fancy things, we can just do simple edits here. Hello, container world. Commit those changes directly to the main branch. Change the main branch, so our YAML file should be running. And really, it's just a matter of how long it takes that to run, which did not take very long, right? Sorry, I meant to be ready to the break 5 minutes ago. I know it's a little bit long, but I didn't want to stop right in the middle. And then when this turns green, hopefully it turns green. If it turns red, we'll definitely jump right to the break. Y'all see the concept there, right? The software has been updated. So traditionally, start sending the user notifications saying they need to update, run an update. Maybe eventually try to push out an update immediately. Well, sure, I'm still not at that part. Now I can go back to GitHub packages because I didn't save that anywhere. Under packages, grab the URL, paste that in. Docker does cache, and notice we already have a bunch of already exist, and then it started pulling things. I noticed it didn't match. It didn't match what it has cached. If it perfectly matches the cache, obviously it's going to start a lot quicker. So like no changes. So Docker images -a. We have this latest repository, which again, if we grab that in a script, would be index 0 of that particular list. It's a two-dimensional list table. So index 0, 1, 2, 0. So the very top one there. Copy that. Docker run -ti, that ID, and we get the updated version of the software. A whole lot easier than the old system, right? And it was pretty much all copy and paste from GitHub. It's automated processes, and they already set it up for us. We just go over there and we have to search for it. There's so many things we can choose that are automated like that. They're built right in. I've been anxious to show those in classrooms because usually in the classroom, y'all have seen it, right? Upload, they show you where the upload button is, that's about it. So that's all they have, and then tell you to submit the link. We don't really get to dive into what's going on there. Hopefully that was something interesting. That went 7 minutes longer than the upper limit of when I went to make it, so it's probably a good time for a break, right? 10 minutes sound good? Sure. My laptop says 7:22, so we'll get back to it at 7:32. And kind of in preview for remote stuff tonight, we're going to look at AWS because GitHub is not the only version out there. So I will see you all in just a moment. I'm going to get some coffee. Awesome.